Okay, so we are continuing our lecture on object-oriented programming. I'm still running the same notebook. Let me just rerun all of these cells, restart, clear all these outputs, and okay. So we defined the point, and we've been so far our definitions of classes have been blank, and we've been just kind of adding attributes to them. We created a couple different functions that modify or pure functions that just kind of return values. Okay, and we have this classes and functions. All right, so we've done all of this. And let's see, here's the modifier function. This is the function increment, prototype versus planning. Okay, so one of the things that we did was we defined time, and then we had this function to kind of increment the time or add two times together. We would take the time and we would convert them into seconds after midnight, or seconds past midnight, I guess, and then we could just add these two integers, and then we could then div mod them back into the time. And I think the last thing we did on Wednesday was we created a method. And so right now our definition of, so this initial definition of class time, capital T time, is blank. There's nothing in there. And we had a function that said, okay, let's take this and print the time. And we then decided to change it a little bit by defining a method. So we redefine our class time, and all I did basically was I just copy and pasted this function, print time, and I pasted it inside the definition of class time. Okay, and now the class has a method. Okay, so inside class time, I just copy and pasted the definition of this function print time, and this defines a method. And so now here is start, and then to call the method, I can just take the object that I created and I can call .print time with no argument. Okay, and this will call the method print time on itself. And right now, the function has the argument time, and it takes the time and it prints out the hour, minute, and second, and so on and so forth in this thing. The convention is that when you are referring to the object itself, the argument that you're going to use is you're going to use self rather than whatever it was before. So, in our earlier definition of the method time, we had time here, which made sense. But because now it is a method inside the class, the convention is to use self. Okay? It doesn't break any. You're not going to throw errors if you put in time or something like that. Right? So because this worked, this didn't throw any errors, but it kind of goes a little bit against our convention, which is to use the word self. So here I'm going to create, I'm going to redefine my class time, and now I have two methods in here. One method is print time, okay, and I do print time self, and basically anytime I call the method print time, it's going to pass itself as an argument in here. So we're going to get this, and then I'm also going to have the take the function time to integer, and we call it on itself, and it's going to return the number of seconds after midnight, and we have this. Okay, so I'm hoping we're able to read this code and it makes sense to us. Okay. So now, again, anytime you redefine a class, it doesn't go back and update the old definitions, right? So if you created an object under like what the old version of time is, those things still exist under the old version of time, right? It's not like when, you know, you bought a PlayStation 4 and then they released the PlayStation 5, your old PlayStation suddenly doesn't update, right? Like if you want the new one, you got to buy the new one, okay? So anyway, so here we're going to just take this new definition of time and create a new object called start. I can do start.print_time and it prints it out. I can do start.time to integer and it converts it to integers, okay? And again, even though I didn't put anything inside the method, it passes the object itself into self, okay? And you know, so far we haven't, the attributes, hour, minute, and second is not part of our class definition. We've been having to kind of create these attributes ourselves manually after we create an instance. But the methods of print time and time to integer are part of our class definition, and so we can call those things. Okay? And then we want to also have this thing, okay, where we convert integers back into time, okay? It's going to convert the number of seconds into a time. It can't be made as a method of a time object because the argument of this function is an integer value of seconds, and there's kind of no object to invoke the method on, right? Because to kind of invoke a method, it has to be something like start dot something, and right now what you would invoke it on is just an integer, and so you'd have to like define a new class of just like integers that represent time, and it's just kind of silly. So we're just going to do integer to time. It's going to return a time object by, you know, we just do, do integer to time, 35,100, and that will convert it back into a time. Okay, then I'm going to add another method, and this is going to be increment the time. So we can take a currently existing time, and then we can add on a number of seconds, okay? And all we'll do is take the current number of seconds, and we will take our current time, turn it into integers, add that to the seconds argument here, right? So I'm calling self.time to int, so it takes, you know, our time 9:45 or whatever it is, converts it into seconds, adds it into this number of seconds, and then what it's going to return is it's going to take that seconds and return it as a time. So if I do this, I can do start is 9:45, and if I print time that, I get 9:45, and we're going to increment it by 1,337 seconds, and we'll call that end, and I can say, okay, what's the time there? If you do 1,337 seconds, which is about 22 minutes and 17 seconds, that's what we get here. Okay, 10:07:17. So that looks good. That looks good. Now, here, when you call the argument, or not the argument, call the method. Okay, the first method in here is self, and it always passes itself as the first argument, okay? And so here, when I called increment and I put in the number 1337, that number goes into the second argument here. So if I did something like this, we get this error because it says 2 positional arguments. Increment takes 2 positional arguments, but 3 were given, and that's because the self is always passed as the first argument, then it takes 1337 and passes that as the second argument, and then it takes this number 460 and tries to pass it in as the third argument and says, you know what, I can't do that because the definition of this method only takes in 2 arguments, right? And you know, sometimes it's confusing because we only see 2 arguments inside here, but what's going on is self is always being passed in as the first argument. So there's there's always an additional argument being passed in there. I'm going to kind of further add more methods to our class definition, okay? And so you can create methods that take in other objects of the same class, or other kind of objects in general. So in here, I'm going to create a function or a method called isAfter. And what isAfter is going to do is it's going to just check to see if another time object takes place after another time. And so this function will take in two class objects and compare them. The first one will be itself, and the other will be, and then the other object will be just some other time object. And because we're expecting the other object to be passed into it to be a time class, we can invoke the method, right? So we can, to compare two times and say, is 11:03 a.m. or 11:03 after 9:45 or whatever it is, you just convert the two convert them to integers, and then you just compare those two integers, okay? And you don't have to do like compare the hours and then compare the minutes and then compare the seconds. And so, the convention here is if you're having two kind of objects here, the first one is always self, and then the other object we just call other. It doesn't throw an error if you use a different name here, but that's the convention. So you have self. So here to kind of make the comparison, I'm going to do self.time to integer, and then compare that to other.time to integer. This whole thing is going to return either a true or a false. And we can see. So here, I will call create a new object, 9:45. Our end, we're going to add 13:37 minutes, and we're going to ask, is end is after start? True? That is true. Start is after the end? That's false. Okay, so that's all we're doing. Okay, is after is just asking, this object, is it after this object? Okay, so always kind of test. Anytime you create methods and it's supposed to return true or false, test them out. Make sure it returns what you're expecting, right? And is after, we named the method is after because anytime you're returning a true or false value, it would be nice to kind of, or it's I guess a nice convention to use a method name that feels like a yes or no question. End is after start, true or false. Start is after end, true or false. That's kind of what we have here. Okay. So far, every time we've created new objects, so far our class definition just has methods and nothing about like what are the attributes that belong to the class, right? And every time I've been doing this, I've been invoking, I've been doing like start is a new instance of time, and then just manually I've been doing start.hour attribute is 9, start.minute attribute is 45, start.second attribute is 0. What we can do is we can use the init method, okay? So I wrote, it's been annoying that every time I redefine start, I have to kind of assign the hour, minute, and second attributes. And so there is a method, and it's a special method because it uses the double underscore, okay? So this is called double under init, okay? And this will get invoked anytime you create a new instance of that class. And so when you use the init method, it's useful to kind of assign values to the attributes that you're going to do, right? So here, just like all of the other methods that we have, the first argument is self, and now I'm going to define the attributes that are part of the class definition that I want, okay? So I'm going to define the method double under init, and inside here, we're going to say anytime we create a new instance of the class time, and we're going to assign whatever argument comes in as hour to the hour, whatever argument comes in as the minute to the minute, and whatever argument comes in as the second to the second. So we got self.hour, self.minute, and self.second. And the default is going to be 0, 0, 0. So that if we don't do anything, we have that. Okay, so now defining a new instance of time, I can just do midnight is equal to time 0, and I don't have to do all of this stuff where I do, back here I would have to do start is time, start.hour, start.minute, start.second. I don't have to do that anymore. I can just do this, okay? And we have that, right? If I wanted a new time, I could do time 9, and the first argument goes in as the hour. Okay, so now this is 9 o'clock, and if I want 9:45, I can just do a new time is time 9, 45. And there we go. All right. Is that okay? So that is the init method, and that's how we can do it. So we're just continuing to add methods to our class definition here. Okay, let me go ahead and give you your first view quiz answer for today, and the first view quiz answer today is the letter A. A as in apple. A. Okay. So init. So again, if you read anyone else's code who's written in Python, you'll often see class definitions, and inside the class definition, you will see stuff like double under init. That's going to show up nearly all the time. Okay, there is another double under method called double under string or double under str. Okay, and this is a special method. So all of the special methods, we call these dunder or dunder methods because they have double underscores. Okay, so dunder string is going to is a special method that returns the string representation of an object. So basically, anytime you call print on a Python object, Python invokes the dunder string method. And so far, every time we wanted to kind of print the time, we've been invoking this method print underscore time, and that's been working just fine. But we can kind of use Python's native terminology here. And so if I just rename, what I'm going to do is I'm going to rename that print time method, okay, to be double under string, okay, a dunder string self, and then now we're going to have this method return the string, okay? So when you call print on, say, time, or you just kind of ask for, what's the string representation of time, the Python's going to invoke this method, and it's going to take the string that gets returned. So a key difference here is back here when we printed time, we called print on this string object. Okay. Now that I'm using Python's dunder string method, we're going to return a string rather than print it, right? Because when you return a string, like the string is the result, printing returns none in Python, right? So print, when you call print on something, it outputs stuff to the screen, but it actually returns nothing. It returns a none. So So I've just taken the same kind of definition and I've just changed print time to double under string, and I've changed print here to a return. So I'm just continuing to refine my definition of this time class object here. Okay, so our definition keeps getting bigger and bigger, but I'm hoping we're still able to kind of read all of the methods and understand each of these things. Okay, so now I'm going to just do new time is time 9:45, and then I call print, and then it prints it out. Okay. All right, so yeah, new time here, is still the time object, but anytime you call print, it's going to invoke this, and it returns the string, and then the string then gets printed out. So this kind of now, being able to see the time, we're able to kind of use Python's kind of native vocabulary rather than, this was fine. new time dot print time or something, we would invoke this method, but to kind of just make it look more, we might say Pythonic, okay, so that it kind of fits in with the the way other objects look and behave in Python. It's nice to kind of be able to just use the regular old print function. Okay, all right, is that okay? All right, so now I want to add additional methods, okay? And so we have something called, so there's more methods that we can do, okay? And one of them is called operator overloading, all right? And this is just like a fancy word for saying, you know what? We have this thing called plus, or times and stuff, and can we use that with some of our objects, right? So Python allows you to take strings, and then when you do plus with them, it joins them together, right? Or you could take lists, and if you do plus, it kind of concatenates them together, which is convenient, right? And so that all of that kind of behavior is enabled through Python's double under methods. So one of the methods is the double under add. Okay, so the dunder add method gets invoked anytime you use the plus operator, right? So here what we're going to do is we're going to say, what if you have two time objects and you want to add them together? Okay, so what if we have like 9:45, and then we have a duration, we're going to watch a movie that's 1 hour and 35 minutes. When does the movie, when is it all over? Okay. So we could do basically like add time. Like if we wanted to add two times together, we're going to create, add this method to it. Okay. So I'm going to define the method double under add, and again, anytime you use a double underscore, it's one of the Python's kind of special methods. And so here we're taking two time objects, and we're going to do self.time_to_int, and take the other time object, other.time_to_int, right? And we're going to add those two integer values, and that's going to be like the total number of seconds. And then we are going to convert integer to time, right? So int to time is a function that exists outside of our class time definition, right? So this is not a method. This is just an outside function that we defined, I don't know, way back somewhere. Int to time, right? So it's not a method. It just we have to kind of find that method in the environment. But when we do that, this will return kind of the new time. So here I've got a time start is 9:45, duration is 135, right? And I can, do print start, and we have that. Print duration is that, and then I can do, what is start plus duration. Start plus duration is going to return a new time object. Unfortunately, we can't see it. So in order to see it, we're going to do print start plus duration, and it tells us that it ends at 11:20. Right? Yeah.
When you leave objects in a Jupyter cell, and you just leave them as the last thing, it's not calling print, right? On that object, like, because you saw something that wasn't the stir of the object, we call print to see the stir, right?
This?
Yeah, so shouldn't that be the call? Isn't what you see there the print of whatever you're doing?
Let me see. So if I call string on this will be the string representation. This is the object itself.
Well, like if you put like x equals 3 in a Jupyter cell, then x is the last line. It'll print 3, right?
Yeah, it returns 3 versus this doesn't return anything, or I don't know. So here, this, like, the object in memory is 3. The object in memory is this object.
So it's displaying like what's the object in memory?
Yeah. So subtle difference.
Okay. I was just confused. I was like, it should print.
Yeah.
Makes sense.
It just kind of, it points to what that, I guess, object in memory is. Yeah. Okay. Okay. So here we did add, and we take 2 time objects and we add them together, and we get the resulting time here. Okay. Now, what would happen if what would happen if I did start plus 1337, right? This returns an error, right? Because what I have to right now, I have to do start plus increment 1337, okay? And then I would have to kind of print this, right? I mean, I guess I can invoke string. This is another way to do it, I think. Oh wait, no. Time object. Oh, has no add. Okay.
Double under string, probably.
Double under string. Yeah. Okay. So I could do that, but I have to call increment rather than plus. Okay. So what we might want to do, right, is we can take the 2 functions, right, and just kind of split them, and depending on what the other object is, we can invoke one or the other. Okay, so I'm going to modify my add function, and we're going to have 2 different functions. Okay, so I have the add time, which says if your self is a time and the other is a time, then you'll basically add these 2 time objects and return the thing. And then and if the self is basically self is going to be time, but the other is an integer, you can use the increment function. And so the double under add will take the self. The self is always going to be the time object, but the other, it's going to check what kind of object is the other. And so here we're going to ask, is the other object an instance of the time object? So we say is instance other time, and if that's true, then we'll invoke the method self.addTimeOther. And if it's not true, then we'll invoke self.incrementOther. Okay, and so the add function is now going to return the result of this function or the result of this function, right? And so this is so we're going to invoke one method or the other depending on what instance the other object is. Okay, so here I'm going to do start.time 9:45, duration time 1:35. Both of start and duration are both time objects, so it's going to invoke the add time. Here I've got start plus 1337. 1337 is an integer, and it's going to invoke the other. This all happens invisibly, okay? Right? We don't, as the user, like once this is fully defined, we don't have to worry about this, and we can just use the plus operator. And Python allows for this kind of flexibility where we're just adding stuff, and we're not having to worry about it. But it's nice, right? Otherwise, we'd have to continue to keep in our head, like, okay, here I've got to invoke add time, here I've got to invoke increment, and things like that. And by designing your objects in such a way where you can kind of just use these existing operators, and they behave in a way that one might expect, then we have this, right? So we can invoke. Just use the plus operator, right? But behind the scenes, what's going on is the plus operator invokes the double under add, and then within double under add, we're detecting what kind of object do we have and dispatching different methods there, okay? Commutative addition. So one thing is the addition operator. The add operator is not commutative. So if I take 1,337 seconds plus start, Python doesn't know what to do, right? Because it sees an integer, and then now we're trying to add a time object, and it says, well, yeah, I don't know what to do, okay? And that's because the integer object doesn't have a way to kind of support adding additional time. But this is probably, I don't know, this may or may not be the behavior we want, right? A lot of times we think of addition as this commutative thing, in that, like, if you do 1337 seconds and add 9:45, or you switch the order of these things, addition, we kind of expect to get the same result. So there is another method called radd. Radd is basically right-hand side add, okay, or right side addition. And so in this case, we're going to do, we have the add function and we have the self. So the right-hand add function, the right side add, is basically just going to invoke the add function. And the right side add just means if the object ends up on the right-hand side of the plus operator, okay? So in this case, the object start ends up on the right side of the plus operator. You can invoke, if you end up in that situation, you can invoke self.add. So basically, this is going to catch instances where, if there was a method where we could do 1337 plus start, okay, if there was an integer method, Python would use that. It prefers just kind of like the existing left-hand side object first. But then if it doesn't find a method, okay, for that, then it's going to take this object and say, is there a right side add argument or a right side add method? And it will allow for that, okay? So our definition just keeps getting bigger and bigger, but now we have an add and we have a right side add. Yeah.
For when we define right side add, do you have to invoke the double under add, or can you just say self plus other?
Self plus other. Maybe. Could we do self plus other? We might be able to. Here, okay. So we'll do this, and then we'll try it out. Okay. So I'll do this, and I'll do that, and that works out. Okay. So the start plus 1337 and 1337 plus start. So now the question is, can I just return self plus other, maybe. Yeah, it works. It works. Okay, self plus other. Okay, great. Cool. Okay. All right. Let me just give you your last 2 view quiz answers. You need 2 more? Right, okay. All right, C and D. C as in cat is the second one. D as in dog is your third one. C as in cat, D as in dog. C as in cat, D as in dog. Okay, all right, so here is the cool thing. Because we've defined double under add here, now the function sum will work, okay? So, because sum just invokes basically a bunch of plus operations. So, so here I can say time 1 is an hour and 20 minutes, an hour and 40 minutes, an hour and 30 minutes, right? How long is this total, right? So we do our own math and we say, okay, that's 4.5 hours. And I can say total is going to be the sum of, T1, T2, and T3. And I can call print the total here. So even though I don't know if this is impressive or not. Like, to me, it's impressive, right? Like I didn't create like a special method for sum, but because Python understands like, oh, you know what, sum is addition, and we have this double under add. Basically, anytime if you use like a double under function, like it will it unlocks access to like certain functions. And so anything that kind of runs off of addition, I guess really in this case, it's just sum here. It unlocks that. Okay, so this is a polymorphic function. Next week we'll look at more object-oriented stuff, and there's like a whole bunch of like really cool stuff that I'm excited to show you guys. Okay, so anyway, that's that. You can add objects at any time, like that's kind of what we were doing earlier until we started using init, right? We were just adding attributes to our objects. But if you have kind of objects of the same type, right? If you have a time object over here and another time object, and they don't have the same attributes, it can be confusing and can lead to problems. And so if you wanted to just kind of check what are all the attributes that exist inside some existing object, you can use vars. And this is just kind of like a lets you take a peek inside the object to see the attributes. And yeah, in the future, as you create classes and stuff, you should always use the double under init method, and that's going and you should define all of the attributes that you're going to be using with this class inside this double under init, so you're not manually creating or adding attributes to the class. Okay, I know that's what we were doing at the start, but that was before I taught you double under init, and now that we've covered double under init, that's when you should create all of the attributes for this thing. Okay, so that's it for today's lecture regarding kind of more of this basic stuff with object-oriented programming, and I'll show you some more object-oriented methods or class methods in Python next week as well. Okay, so we'll end here for today. Have a good weekend, and we'll see you Monday.